This video covers creating rectangles using the various parameters provided in the design editor. In this case, we're using a 10-inch OD pipe with a 1/2 inch wall thickness. First is the corner radius. The corner radius applies to the cut surface that you've selected, inner or outer diameter. So an OD cut will have the 3/4 inch corner radius on the outer diameter, while an ID cut will have the corner radius on the inner edge of the cut. It's best to avoid creating sharp corners that will overburn. Here, for an OD cut with a smaller corner radius, the inner corner becomes sharp. Here the cut path shows that the torch will spend some time pivoting in those corners, even crossing back a bit. A plasma torch will overburn in these sharp corners, while a gas torch won't overburn quite as much. So try to keep at least some arc radius on both the ID and OD of a rectangle to prevent overburn. The corner radius can only be half the distance of the X across length. So if I make this 1 inch, the two corners join to become a half circle. But if I make this corner radius too large, the cut will show an error. This checkbox determines if the bevel is off the part you are cutting or the bevel is relative to the mate part. So with this checked, the bevel will be 35 degrees off the part being cut. Unchecking this will set the bevel relative to the mate part. Here I'll toggle the mate part on, and the bevel is reduced to be 35 degrees off the mate part. Here it's a little smaller. Now I'll check it back on again to show you that the bevel grows again to be off of the part being cut. Next is how the X length is measured. This value can indicate 3 different measurement types. First one is a chord, or a straight length across the selected cut surface, which is ID or OD. This measurement is useful for an insert where you select the ID cut surface and set the X length to the size of the insert. So here I set it over here to OD, and the chord length is now on the outer edge of the cut. If I change the bevel angle to 0, you'll still see a bevel top and bottom. That's because we're still beveling off the part, and those perceived bevels are actually 0 bevels straight up and down. If I make that bevel off the mate part, then you get a common slip fit cut. The next type of measurement is distance around. This is the distance around the pipe circumference of the selected cut surface, ID or OD. In this case, the X length is 4 inches around the inner diameter cut surface. If I change the cut surface to OD, then the X length is around the outer diameter of the pipe. The final measurement type is angle around the pipe. And here you can see that 4 degrees around does not make the rectangle large enough for the specified corner radius. Changing this to 45 degrees makes the rectangle size around 45 degrees on the outer cut surface. Changing the cut surface to ID makes the rectangle opening 45 degrees wide at the inner edge of the cut surface. You can widen the cut all around by adding a root gap. The root gap will widen on X length by the chord distance for the chord and angle measurements. For distance around measurement, the root gap is added about the pipe circumference, though with normal root gaps that measurement won't vary perceptibly. Made angle and made offset parameters are the same as with holes. And here the mate offset shifts the rectangle mate part off to the side of the pipe. Next up is rectangle rotation. Here I'll rotate the rectangle by 20 degrees, or -20 to rotate it the other direction. Changing this angle will turn the rectangle into a parallelogram. Using the same number as the rotation will make it vertically parallel, but you can set this as needed. Note that the X and Y lengths are calculated before rotating the part so that measurements are kept simple. The Y length measurements can be modified for a parallelogram. Here I have a Y length of 6 inches that is measured centerline to centerline before rotation. But if I check the parallel Y distance box, then the Y length will be 6 inches between the parallel left and right edges. This remains true even if you rotate the rectangle. Here's an offset that goes past the pipe edge. I'll toggle the mate part, and you can see that the cut causes the mate part to stub against the part's centerline plane. Checking the through checkbox will project the rectangle through to the other side of the part. This will create flat bevels on either end of the bumper cut. Checking fixed bevel tilts the bevel to the bevel angle for the entire cut. Now I'll create a repad. First, setting my bevel angle to -35, so in this case my repad has a positive bevel. But creating the cut path, one can see that the cut path and lead in are on the wrong side, and the torch is going the wrong direction for keeping the repad. Checking the switch cut side moves the cut to the outside as desired. But now note that the outer corners are too tight. This can be fixed by increasing the corner radius or by making this an OD cut so that the corners naturally flare out from the specified corner radius.